Hi everyone. So this week experiment is 10b, which is enthalpy. So enthalpy is a thermodynamic property or a function. It relates to the internal energy of a reaction. Okay. Normally we measure the enthalpy at a constant pressure. If the enthalpy we are trying to find out is a reaction, we also call that change as heat of a reaction. We're not going to do part A, but we're going to do part B, where we're going to find out what is the enthalpy of formation of magnesium oxide from magnesium and oxygen. So our goal is to find out the enthalpy of formation of magnesium oxide. Magnesium oxide is been formed from magnesium and oxygen. We cannot perform this particular reaction in the lab. So what we're going to do is, instead we're going to perform 3 different reactions, and we're going to manipulate these such a way we get this target reaction by adding these 3 reactions together, which is also called the Hess's law. You guys have seen what is Hess's law when we talk about the pre-lab assignment as well, where if you know enthalpy of reactions, few reactions, and when you add it up you can get the enthalpy of the formation of reaction at the very end, which is for your target reaction. Okay, so the 2 reactions that we're going to perform, you're going to mix magnesium with hydrochloric acid, and then it's going to give you magnesium chloride and hydrogen. We're going to find out enthalpy of formation or heat of reaction for that particular reaction, and then we're also going to react magnesium oxide with hydrochloric acid and find out what is the heat of the reaction. And then once we find out enthalpies for those, and we also know the enthalpy of formation of water, with that we can find out enthalpy for the target reaction. How are we going to perform the reaction? So you will watch the virtual video where you're going to take, let's say, you're going to take 60 milliliters of 1 molar hydrochloric acid, and you're going to measure the temperature of the hydrochloric acid. And then you weigh about 0.6 gram of magnesium and place in the calorimeter. Let's say this is your calorimeter. So you add 0.6 grams magnesium. Okay, and to this one you're going to add 60 milliliters. By using a graduated cylinder, you add 60 milliliters of hydrochloric acid, and then you're going to put a lid, and then you put the thermometer, mix it up and find out what is the highest temperature that the thermometer reads. Okay, and then what's going to happen here, you have magnesium plus hydrochloric acid. It's going to give you magnesium chloride plus hydrogen gas. So this is the reaction that we want, enthalpy of formation. Now when this particular reaction is taking place, it releases heat to the surrounding. Your surrounding, where this HCl is mainly water, hydrochloric acid. Hydrochloric acid that you put, this 60 milliliters, is not solely hydrochloric acid. It has a lot of water in it. A very small amount of hydrochloric acid, but more of the water. So when this particular reaction is taking place, the water in hydrochloric acid is absorbing that heat. So as a result, when you get the temperature, you will see the temperature increases. But this temperature increase is being felt by this water. Okay, but how does the water get that heat change? Due to this reaction. Okay, and also we're going to do another reaction where you take 1 gram of magnesium oxide this time. First it was magnesium. In here you had magnesium. Now you have magnesium oxide. You put 1 gram. And then you also put 60 milliliters of water. Put the lid. And then you stir it. And then you're going to get the temperature of the water. Why the temperature increases? Again, because when magnesium oxide react with hydrochloric acid, it's going to produce magnesium chloride and water, H2O, 2HCl. So when this particular reaction is taking place, it releases heat, and this heat is being absorbed by the water. So this is HCl, but it mainly water. So water absorbs the heat, so you will see a temperature increase. So you measure the temperature. Okay, so those are the two readings that you're going to get. And in your data sheet, you will be given those data. Okay, so you will see in your other sheet, and this is for the part A, not going to worry about that. Part B, initial temperature of the HCl solution, meaning before you put the hydrochloric acid to your magnesium, that was given to you as 22.2 from your data sheet Celsius. And then the mass of the magnesium, you needed to take 0.6, but 0.609 to be exact, 609 grams. And we need to find out the moles of magnesium. If the mass of the magnesium 0.609, how do you find out the moles? You're going to divide it by the molar mass of magnesium, which is 24.3. And that will be 0.025 mole. So this is the molar mass, grams per moles. Okay, 0.025. You're going to write it down here. And then highest temperature of the mixture is recorded as 61.6. Right? And who felt this temperature change? It was felt by the water. Okay, so the delta T of the mixture is going to be final temperature minus the initial. So this is the final temperature, initial. So you get the difference between these two. So the delta T would be, when you subtract 22.2 from 61.6, that would be 39.4 Celsius. Okay. And then the heat gained by the solution. Remember, water felt this change. Now we want to find out the heat gained by the solution. How do we find out the heat? Which equation are we going to use? We're going to use this equation, which you know, Q equals mc delta T. Now, whose Q we are going to find out? It's the heat gained by the solution, and our solution is mainly water. This Q water. Okay, water temperature increased because your reaction, which is magnesium plus hydrochloric acid, when it react these two together, it form magnesium chloride and hydrogen gas. It released heat and water absorbed it. So heat is being absorbed by the water, so it is a positive value for water. But for the reaction, it's going to be negative. Okay. So what is the mass of the hydrochloric acid? We took 60 milliliters. Now 60 milliliters hydrochloric acid, which is almost the same amount as the water. Okay, and then the density of the water is 1 gram per milliliter. So milliliters and the mass are going to be the same. Since the density is 1, so mass we can consider as 60 grams. And then the specific heat for water, 4.184 joules grams per Celsius. And then the delta T, 39.4. So that is the heat gained by the solution, right? And that value, when you do the calculation, it would be 9,891. 9,891. I'm going to keep it in 4 significant figures. Okay? That is the heat gained by the solution. Meaning, this is what experienced by the water. Now, our reaction is magnesium reacting with hydrochloric acid, giving you magnesium chloride and hydrogen gas. This particular reaction lost heat and then the water absorbed. So the heat gained by the solution is this. So then the heat lost by the reaction is going to be the same amount but opposite sign, because it is an exothermic reaction for magnesium and hydrochloric acid. So that will be negative 9891. Same amount but opposite sign, because the heat is being lost by the reaction. And then the next one, heat of reaction per mole of magnesium. So you take the same amount, 9891, and this is in joules. To find out per mole, we had 0.025 moles. So you need to divide this by 0.025 moles to find out what is the heat lost by the reaction per mole of magnesium. You take this number, you divide it by 0.025, and that would be negative 39. It's a big number. 5640. 5640. Let me make this one 5640. That's going to be joules per mole of magnesium. And the next one, you need to convert it to kilojoules. Heat of reaction per mole of magnesium, joules. Now you need to convert it to kilojoules per mole of magnesium. So basically you divide it by 1000 to convert it to kilojoules, and that would be negative 395.6. Negative 395.6. I divided by 1000. Okay, that is the heat of reaction per mole of magnesium. What we found out is the delta H for this particular reaction per mole of magnesium. Okay. Okay. So now the next part. Initial temperature of the HCl solution. Again for this one, 22. These are in your data sheet, 22.0, and then the mass of the magnesium oxide, and you are supposed to take 1 gram, and the exact amount that is taken is 1.011 mole of magnesium oxide. So you take this 1.011 grams, you divide it by the molar mass of magnesium oxide. What's the molar mass of magnesium oxide? Magnesium is 24.3, oxygen 16, so 40.30. So you divide it by molar mass of magnesium oxide, grams per moles. That will give you number of moles. Again, that 0.025. Check to see if these numbers are correct. Okay, I could be doing some mistakes. And then the highest temperature of the mixture, 36.9. You find this data in your data sheet, and delta T would be 36.9 minus 22. That would be 14.9. And then heat gained by the solution. Again, the same process like before. You can calculate the heat gained by the solution. We use 60 milliliters of hydrochloric acid. We can use the same equation here. Q water MC delta T, mass of the water 60 grams, and then the C 4.184, but we can change the temperature. So the temperature going to be 14.9, delta T 14.9. Heat gained by the solution. So 60 grams times 4.184 times 14.9, heat gained by the solution over here, that would be 3740.5 40, so 0.5 joules. That's the heat gained by the solution. Heat lost by the reaction would be the same amount but opposite sign, negative 3000 740.5. Heat of reaction per mole of magnesium oxide, you take this number and you divide it by the number of moles, which is 0.025. You take this number and you divide it by 0.025 to find out the heat of reaction per mole of magnesium oxide. Okay, that would be 1496.20. Big number again. Okay, when you divide, that is per mole of magnesium oxide, and converting it to kilojoules, you divide it by 1000, that would be negative 149.6. Okay, and then that is going to be the heat of reaction per mole of magnesium oxide. And then the heat of reaction of water is given to us, negative 285.9. And then the heat of reaction per mole of magnesium from the previous reaction that we calculated, that amount is negative 395.6. Now we have the three reactions that we need to calculate the enthalpy of formation of magnesium oxide. Remember, this is the reaction that we want to find out the enthalpy. Magnesium plus half oxygen giving us magnesium oxide. So we want to find out the delta H for this one. And the three reactions that we know is, first reaction, magnesium with HCl, magnesium chloride plus hydrogen gas. And we found the enthalpy for this reaction, which is negative 395.6. We calculated that. These are all kilojoules per moles. Okay. And then we also calculated magnesium oxide with HCl giving you magnesium chloride plus water. We calculated enthalpy of formation of this reaction as well. That is negative 149.6, again kilojoules per moles. And then the water is hydrogen plus half oxygen. Formation of water is given to us delta H as negative 285.9 kilojoules per mole. So these are the three known enthalpies. What we want is, this is our target reaction. Now you can see we want magnesium to be in the left side. Magnesium oxide needed to be in the right side. Magnesium, we find it in this side. Magnesium oxide, magnesium. And then the magnesium oxide is in this side. But here magnesium oxide is in the left side. So what do we need to do? We need to reverse this reaction, right? And then the oxygen needed to be in the left side. So the water reaction, we can keep it. What we're going to do is we're going to reverse the second one. When you reverse it, it would become MgCl2 MgCl, it's becoming light. MgCl2 plus water. I'm reversing that second reaction. MgO plus 2HCl. So when you reverse, what happened to the sign of your delta H? It would become positive, 149.6 positive. Okay, not negative anymore, so that's a positive number. Now when you add the three reactions, so this one, and this, when you add these three together, you will get your final reaction. 1, 2 and 3. I'm going to look at these three. 1, 2, 3. Okay, so when you add 1, 2 and 3, 1 we have magnesium on the left side, so you keep magnesium, plus it has 2 HCl, so we're going to cancel the ones that we don't need. So the 2 HCl here get cancelled with this HCl, and then MgCl2, so we're going to keep this, there's MgCl2 here, and then MgCl2, that get cancelled. Okay, and then the hydrogen, so this hydrogen get cancelled with this hydrogen. We are looking at 1, 2, 3, that the numbers 1, 2, 3 reactions, and then we have half oxygen in the third one, so you write that down, half oxygen. And then what else? So the water, we have water here and water here get cancelled. And then what else? We are left with MgO. You just write that down, MgO. So magnesium plus half oxygen giving you magnesium oxide. We just added 1, 2, 3. So we reverse the magnesium oxide reaction. So the three enthalpies that you need to add, you add negative 395.6, and you also add negative 285.5 and positive 149.6. When you add these three terms, you will get the enthalpy of formation of magnesium oxide. So you add negative 395.6, negative 285.9 and positive 149.6. When you calculate these three, you will find the delta H formation for magnesium oxide. And then you can write down that answer over here. And then the textbook value, delta H formation of magnesium oxide, I Google it, you guys can Google it too. It came to be 601.7. That is the literature value, 601.7 negative. But you calculate from the values that I've given you here and write down what is the answer you're going to get. Okay, so that is how you find the formation, delta H formation for magnesium oxide by using Hess's law. Okay, that's it. Bye-bye.